Our next demo this morning is on Compute for Cancer. Would the Compute for Cancer folks come on up? Get started here. I'd like to introduce Gordon Weiss, Isaiah Blackburn, and Chris Kitchen from Compute for Cancer. They are a Kansas City and San Francisco nonprofit. They're taking their combined efforts in artificial intelligence and smart communities and taking advantage of the advanced networking that's available in these communities to do something that's pretty unique. I'll let them tell their story, but I'm going to come back later and tell you how important I think it is. So, Isaiah?
Hi. Is mic on?
Yep.
Hi, everyone. My name is Gordon Weiss. I'm from San Francisco. Thank you, Glenn, and the entire Usignite team. I want to express gratitude from our team to be here today and present to you. I'm going to start off with a story about my 75-year-old mother. Last year, I took her to Burning Man for the 4th time. For those of you who don't know, Burning Man is an ephemeral city in the desert for 80,000 people. It's a very interesting, inspiring place. We took a bike ride one night out to Sunset to look at art. My mom asked me what I've been up to for the last year. And I told her that processing power is a massive underutilized resource. My mother's 75, my father's 93. They've both been through several bouts of cancer, okay? So I'll say it again. The world is an abundance of processing power. And our mission is to take processing power and to use it to solve problems. Specifically, Compute for Cancer is harnessing the world's excess processing power and focusing it on researchers to solve problems for cancer. We have multiple initiatives for this project. One is with Usignite and the Genie Network. And another, we have a product. It's an application we used. We used with David Anderson's source code from UC Berkeley. And we plugged our application in that we built into a children's cancer problem. And it started returning results. With the help of Usignite and the Genie Network, or 1 million downloads of our app, we'll be the fastest supercomputer on the planet. Researchers uploaded this children's cancer problem online last January. We're about 95% solved of this children's cancer problem, so 5 months. It's a long time for one problem. With 1 million downloads, that problem can be solved in weeks, but more likely days or even hours, minutes. We want to find out. We can all do this. My partners, Isaiah and Chris here, are going to explain in more detail how we can achieve these goals.
Thanks, Gordon. Looking for the clicker here, sorry. Cancer researchers face an access problem. We all know data. There's a lot of hoarders of data. They don't like giving it up. But even if cancer researchers had access to the data, a lot of the academic and individual researcher doesn't have the tools to analyze that data. And even if you had the tools to analyze the data, they don't have the required processing power, computing power to run through that analysis. And Compute for Cancer is addressing all 3 of these chicken and egg access problems. So what do you address first? We're attempting to address all of them. So let's first talk about the access to resources, and Gordon did a great job of setting this up. Our mobile application that you could download out on the App Store today runs in the background. That's why we can't show you a demonstration, because it's running in the background on your phone, but it's only running when you sleep. You're connected to Wi-Fi, and you have 90% battery charge on your phone. I saw that AT&T was a sponsor, and I visited their booth yesterday. To understand the potential impact, if you combine just the retail store Android phones at the 4 largest mobile carriers, That's over 250,000 mobile phones that could be combined together into a supercomputer. That would be 25% of our goal of that 1 million downloads. That would equal the largest supercomputer on Earth. So how does this translate to impacting the researcher? There are well-funded research organizations, and they could pay for the required computing power. But there are a lot of researchers out there that cannot. Typical computing power for large simulations, and this even came from analysis from David Anderson out of Berkeley, for instance, could cost up to $40 million for access to a supercomputer. Leveraging Compute for Cancer would bring that cost down to the researcher to under $100,000. So the tools, I mentioned, even if you have access to the tools, how do you analyze it? And there's a big gap with these tools. And what we'd like to do is leverage some of the tools that we're working with, integrate them with the Genie network and leveraging Usignite, whether it's a multiphysics simulation tool or a visualization engine, or even an algorithm mixer that allows you to run different analyses. All these tools need to be easy to use for researchers, because a lot of researchers don't have a computer scientist or a data scientist in their back pocket to help them work with these tools. And from here, I'll have Chris highlight what we're addressing as far as access to data.
Thanks, Isaiah. What we have is a whole lot of gigantic problems, and what we simply need to do is break them into tiny mosaic pieces that can be distributed to cloud computing, specifically mobile or Internet of Everything, Internet of Things. And with that, we can refine that data after it's been computed with Genie tools and artificial intelligence to essentially make a slice of the future. The technology's here, the future's here, just not evenly distributed. So basically, we're only limited by our imaginations, and hand this back over to Isaiah.
Thanks, Chris. Anybody out here understood that? Please email us, because we need the help. But Chris is spot on. So I'll tell a little story about this slide. What's interesting, when we say we're enabling the genius on Genie, we got all the way to the final production and misspelled genius. And I told our team, how in the hell can we say we're enabling the genius, we can't even spell it? Or at least Chris and I have a reason. We're both dyslexic, so we're going to miss that one 100%. But we did run this by 10 other people, and we all missed it. So, but our true impact is enabling the genius on the Genie network. And we see this as a convergence where IoT meets distributed computing. It starts at the user with the IoT device. It could be a connected car, it could be your mobile phone, it could be a sensor. Right now, we're just leveraging your processing power from the sensor. But it could be important health data that you want to provide to the Genie network that runs through a simulation in near real time. So Compute for Cancer will sit on the edge, enable that, interact with the Genie network, the Internet 2.0, but then all funnel in through the tools that I talked about, that whether you're an academic researcher or an independent researcher can access.
Thanks, Isaiah. We need your help removing the roadblocks. Facebook's created these solar drones. Google has their loons. They're opening up the planet for information. One of our advisors, Eric Weinstein, often speaks about unlocking the geniuses and scaling human intelligence. In fact, he always says, we're all born geniuses. But we're taking this one step closer. We want to unlock the genius on the Genie network. As Chris would say,
Genie we want to let the genie out of the bottle. So, thank you.
Well, how can you help? We have our application downloadable. It's in beta. It's not fancy, but it works. It's downloadable on the Google Play or Amazon Kindle. If you have iOS, you can share it with your friends. You can even donate. ComputeForCancer.org. Here's our social handles. Thank you. It's a great pleasure being here.
Thank you.
Lauren.
Thank you. Thanks so much. Thank you so much, Gordon, Chris, Isaiah. I think this is a very interesting thing. If you have that networking foundation in your city, you can connect the PCs, you can connect the unused servers and businesses together at night and actually solve real problems that will help to cure cancer. In order to test the efficacy of drugs, they need to go and simulate what a drug would look like attacking the protein coat of a cancer cell to see if that would go and latch on and make a difference. So if this is something that you think would make a difference in your community, in your city, one of the things we at Usignite would like to do would be to organize a set of cities to go and work with this crew and see if your city can't make a significant difference by using its network, by using its ability to go and help unused machines go and fight cancer. So let us know if this is something you think you would like to do.